Hello guys, today we'll be learning about arrays. Before jumping onto arrays, let's understand how primitive data types are stored in the memory. So when you declare a primitive data type, let's say int. So when you declare int, what happens is the memory manager looks out for 4 bytes of storage because int takes up 4 bytes of your memory. If it were character, it would look up for 1 byte of memory. So now when you declare int a and initialize it to 5, what your memory manager does is it finds this empty space that is from 4000 to 4004 and stores the value of 5 in this. All right. So as you can see, each box here represents 1 byte of memory. This is extended over here. Each box here represents 1 byte of memory. So now that we have understood how primitive data types are allocated in the memory, let's jump over to what arrays essentially are. Arrays are sequence of data type of homogeneous value or same type. So if you want to declare an array, the syntax that you would have to use is first you would have to declare the data type of the array, then you'd have to declare the name of the array, then you'd have to state the size that you want your array to occupy. So for example, we have here integer, that is our data type, the array name, that is ARR, and then the size, that is 5, inside the square brackets. So this will declare an array of size 5 with its name as ARR. Alright. For example, let's say we have declared integer, this is the data type, array, this is the name of the array, and size 5 inside the square brackets. Now, what happens in the memory manager is that it takes up a size of 1, 2, 3, 4, and 5. Uh, 5 integer values. It takes up the space for 5 integer values, and it stores null in all of them. So it stores 0 in all of these spaces, right? Uh, Now, why only 20 bytes? This is because the data type that we've specified here is int, and the space that's occupied by one int is 4 bytes, this whole 4 bytes, and that is equivalent to this one block. So when you declare 5 such integers, you need a space of 5 into 4, that is 20 bytes. So in general, we can say that the total storage occupied would be equal to the size of the array into the size of the data type. Here, as we can see, the size of the array is 5, and the size of the data type is int, and the size of int is 4 bytes. So the total storage occupied would be 5 into 4, that is 20 bytes. So if we start from 4000, it'll occupy till 4020. This will be the total memory that will be allocated to integer array. The major disadvantage that the array faces is that its size is static and is not dynamic. So what that means is that its size cannot change. So once you set your array size, it cannot be changed. In C++ and C, arrays have a zero indexing system. Zero indexing basically means that let's say the size of int ARR was 5. So ARR will go till 4 and not 5. So in the memory allocation system, what this looks like is uh, the first block would be called by ARR 0, right? This will be the first block, whereas the second block would be called with ARR 1 and so on till the last block that will be called from index 4. And there you have it. So now here we have declared int r as 5. Now let's see how this plays a role. So let's say if you had declared r of 0 as, because the indexing starts from 0, so as 1, all right, and this is not, yeah, so r of 0 as 1, then you had declared r of 1 as, let's say, 2, and r of 2 as 3, and r of 3 as 4, r of 4 equal to 5. All right. So after this, what would happen is the memory that was allocated to integer ARR would be filled by these values. So 1, 2, 3, 4, 5. It gets filled up with these values. Now, if you declare, let's say, int A equal to 3, all right. So the memory manager would find 4 more bytes of storage that are free. And as you can see, 4020 to 4024 is free. So it will place this 3 in that space. And now when you tell your memory manager that I want to store one more value in int ARR, it won't be able to do so because 3 is already stored in front of it. That is the biggest disadvantage that arrays face, that they cannot extend their memory. Also, let's say you didn't store for these two values, the third index and the fourth index. This will result to your memory being wasted, and 4 and 5 won't be stored, whereas these two memory blocks will still be reserved for int ARR, and a garbage value or null would be stored in this. So that's all for today, guys. I hope you like the video, and if you have any doubts, if you have any feedbacks, do leave them in the comments below. I'll be happy to reply to them all. Do share this video, like this video, and furthermore in this series I'll be posting about how to implement the array on C++ and C. So do follow this playlist.